here we have a problem where we will use the energy equation again to solve for here we're solving for the maximum distance that this spring has to travel, and that will be compressed. When we do this problem, we need to take into account the energy of the cylinder mass and the energy of the force from the spring. So let's get started. T1 minus T2, which is the kinetic energy, plus the potential energy from 1 to 2 equals 0. And we're to solve this in two conditions. One condition where the problem is linear, and one condition where the problem is nonlinear. And from that, you can calculate the difference that doing a true calculation, I guess you could call it, versus a back the napkin, just let's see what this problem will be. So, at T2, the velocity will be 0, so we don't have to worry about that. And T1 will be 1/2 mv0 squared. And first, let's take into account the spring as a nonlinear component, and that will have to take the integral from 0 to the maximum displacement times this force equation, 400x plus 20x squared dx. And that will give us a problem that is force times distance. Then we'll need to take the force times distance of the mass of the block, and you can do conversions to make sure that it's in the correct English units. And here it's nice because the 150 pounds is equivalent to that force. So that is the force of C times the displacement. Let's plug in what we know, and we can solve for here, which is the maximum displacement. And let's see, you'll have to solve for mass here using the slugs, which is fun in English, and that is 150 over 32.2. And this velocity is 12, 150, and we're solving for that. And in the end, you'll get that it is 0.377 feet. You may have to convert that into inches. That looks kind of small, but there's your solution in feet. Now let's calculate it without this nonlinear component, but we'll be using the exact same thing. 1/2 mv0 squared minus 0 to delta 400x dx plus c equals 0. And solving for that once again gets us delta 0.406